Okay, so big exam tomorrow. I know you've been cramming deep learning, but let's make sure you've got this one crucial topic down cold. Explainable AI. Don't worry, we'll run through it nice and quick. You'll be set. Let's get started. So let's start with the big question, the one that really gets to the heart of everything we're about to talk about. How do you trust a decision you can't understand? I mean, seriously, think about it. If some AI says no to your loan application or tells a doctor what's wrong with a patient but can't give a reason, can we actually trust that? That's exactly the problem explainable AI, or XAI as we call it, is trying to fix. And this right here is why we have that problem. It's what everyone calls the black box. You know those super powerful, super accurate models you've been studying, like deep neural networks? Well, a lot of the time they work in a way that's, well, totally opaque. You feed data in one end, you get an answer out the other. But what happens in between? It's a complete mystery. The result is just there. It's unexplainable, which means it's totally unaccountable. Okay, here's our game plan, kind of like a quick cheat sheet. We'll hit the black box problem, then look at how XAI cracks it open. We'll check out a map of XAI methods. Pay attention there, that's definitely exam material. Then some real-world stuff, and we'll finish with the big trade-off you need to know. Sound good? Let's go. All right, first up, the black box problem. So why are these amazing AI models so mysterious? Why can't we just pop the hood and see what's going on inside? Well, the simple answer is they're just unbelievably complex. A deep neural network isn't working with a straightforward set of if this, then that rules. Not at all. It's this enormous, tangled web of math and statistics, with millions, sometimes billions, of little knobs or parameters, but it tunes all by itself during training. The path from an input to an output isn't a straight road. It's this crazy, non-linear journey through that web. And for a person to try and trace that path back, it's pretty much impossible. So, if we can't just look inside, then what? Well, we get clever. We build a whole new area of research dedicated to creating tools to, pry that box open. And that, right there, is explainable AI. Now, this is your key definition. If you're going to memorize anything for the test, this is it. Explainable AI, or XAI, is all about creating AI that doesn't just give you an accurate answer, but also gives you a clear, easy-to-understand explanation for why it made that decision. It's about getting both the what and the why. It's really about building that trust right into the code. And this quote really drives the point home, right? This isn't just some abstract idea for a paper. It's about real-world consequences. Think about it. Who is responsible when things go wrong? If a self-driving car crashes, who's on the hook? Without explanations, you can't answer that question. It's a total mess. Okay, here's the classic example that everyone uses, and for good reason, it's perfect. So researchers train an AI to tell the difference between a husky and a wolf. And it gets really, really good at it, super high accuracy. But then they use some of these XAI tools to peek inside and see how it's doing it. And what they found was crazy. The AI wasn't looking at the dog's fur or its snout or anything about the animal. Nope. It had just figured out that in most of the training photos, the wolves had snow in the background. It took a lazy shortcut. It learned the wrong thing. And without XAI, no one would have ever known. Which brings us to the really important part, the how. So how do we actually make AI explainable? What are the tools in the toolbox? All right, don't let this chart scare you. It looks like a lot, but we can break it down pretty simply. Basically, all these different XAI methods get sorted by a few things. But for your exam, you really just need to focus on two big ideas: the scope of the explanation and the stage where it's used. First up, let's talk about scope. You can have a global explanation, which is like trying to understand the model's overall personality. You're asking, how does this thing work in general? Then you have a local explanation. This one is super specific. It's not about the whole model, it's about one single decision. It answers the question, why did you label this picture a wolf? Or why was my loan application denied? See the difference? Big picture versus one specific moment. Okay, the other big category is this stage. You've got ante hoc. That's a fancy Latin term for before the fact. This is where you decide from the very start to use a model that's inherently easy to understand, like a simple decision tree. We sometimes call these glass box models because you can see right through them. The other option is post hoc, which means after the fact. This is what you do when you already have a complicated black box model. You take it after it's been trained and you use other tools to try and figure out how it works. Okay, so we've got the problem and we've got some methods to solve it. But where does this stuff actually matter? Why is everyone talking about XAI all of a sudden?
Well, it matters most where the stakes are highest. We're talking about fields like transportation, medicine, finance, places where a wrong decision from an AI isn't just a funny glitch. It could literally affect someone's life, their health, their money. In these areas, explainability isn't some extra feature. It's an absolute must-have.
I mean, just think about it, right? For a self-driving car, you have to know why it chose to brake suddenly. In medicine, if an AI suggests a diagnosis, a doctor needs to understand the logic behind it before they act. And in banking, when an AI is approving or denying loans, we need to be able to check its work to make sure it's being fair and not discriminating. It's common sense. And this brings us to the last big idea. And honestly, this might be the most important concept for your exam. This is the central challenge, the one thing that everyone in this field is wrestling with. And this chart says it all. This is the key takeaway. It shows this fundamental trade-off in AI. So you've got performance or accuracy going up the side, and you've got explainability or how easy it is to understand along the bottom. And what do you see? As one goes up, the other tends to go down. The most powerful models are usually the hardest ones to interpret. So, down in the bottom right corner, you have your simpler models, like logistic regression. Super easy to explain how they work, but they're not always the most powerful. Then, way up there in the top left, that's where the deep neural networks live. They are absolute beasts when it comes to accuracy, but understanding why they're so accurate, good luck. They're the classic black box. So, what's the whole point of XAI then? It's right here. The goal, the dream, is to break this trade-off. The whole field is trying to invent new techniques that push us toward the top right of this chart. We want to get to a place where we can have both incredible accuracy and perfect explainability. That's the holy grail. All right, so as you go into that exam tomorrow, and even after, as you start working with this stuff, I want you to keep this final question in your head. What's actually more important for the future of AI? Having flawless predictions or having the ability to question them? Think about that. Okay,